Now we turn to the list as an abstract type. Let's list the operations it offers and the rules it must always keep. These are the operations of the doubly linked list. First, create. It makes an empty list. Both handles start empty, so head becomes null and tail becomes null. There is no error case. Second, insert front. It adds a new value as the first node. The one thing that can go wrong is that malloc fails. If it does, the list is left unchanged. Third, insert end. It adds a new value as the last node. This costs big O of 1 because we keep the tail pointer ready. We do not walk to the end. As with insert front, the one thing that can go wrong is that malloc fails, and then the list is left unchanged. Fourth, delete node. It removes a node that you already hold a pointer to. We call that pointer X. The one rule is that X must be a live node in this list. Now the two walks plus the ring's own traversal. Fifth, traverse forward. It visits every node from head to tail. There is no error case. An empty list simply visits nothing. Sixth, traverse backward. It visits every node the other way from tail to head. This is the new power that prev gives us. There is no error case. Seventh, ring traverse for the circular list. It visits every node exactly once, starting anywhere. You stop when you come back to the start node, not when you hit null, because there is no null. One warning before we move on. There is still no index. To reach a node by position, you still walk from head or from tail. The win this chapter adds is not indexing. It is big O of 1 delete of a node you already hold. These are the rules that must always hold. First, for every inside node x, x.next.prev equals x in words, go one step forward, then one step back, and you land on x again. So a backward walk from x arrow next must return to x. Second, the mirror rule. For every inside node x, x.prev.next equals x, go one step back, then one step forward, and you land on x again. So a forward walk from x arrow prev must return to x. Third, for a plain non-circular list, head arrow prev equals null and tail arrow next equals null. These two nulls mark both ends. They are the stop condition for each direction. The circular variant closes the ring instead of ending with null. So, fourth, tail arrow next equals head, and head arrow prev equals tail. The ring closes at both ends, and there is no null terminator here. Fifth, following next from any node comes back to that same node, and following prev comes back too. Both walks return to where they started, so the ring is unbroken. Sixth, the edge cases. An empty ring has tail equal to null. A ring of one node links to itself both ways, so n arrow next and n arrow prev both equal n.